This is chapter 6-5, Trapezoids and Kites, part 2. Please copy your cards, and we're going to move on to trapezoids. To begin, we need to know that a trapezoid is a quadrilateral with only one pair of parallel sides. Right? So here's my trapezoid A, B, C, D. Okay? The only two parallel sides, and I know that because of the symbols here, AB is parallel to DC. They're not the same length. We just need to understand that they're parallel. Okay, so AB is parallel to DC. That does not necessarily mean that AD is congruent to BC either. Okay, because we can have different shapes of trapezoids. All you need to know again is that a trapezoid is a quadrilateral four-sided polygon with only one pair of parallel sides, called bases. So AB, because it's parallel to DC, both AB and DC are both called bases. Okay? Two pair of base angles, and our base angles are these. Okay? So this is our base angle D, base angle C, base angle B, and base angle A. Doesn't necessarily mean that they're congruent to one another. We just need to understand the angle A, B, C, and D are the base angles. And we'll get into when they're congruent. Okay, so again, a trapezoid is a quadrilateral, and you have only one pair or one set of parallel sides or segments, AB in this case, and DC. All right, let's go further. There's a special type of trapezoid called an isosceles trapezoid. An isosceles trapezoid, come on, computer. All right, looks something like this. We still have bases or legs that will be parallel and opposite to one another, but the sides or the segments that are not parallel will be congruent on an isosceles. Remember, at least two sides are congruent. In this case, this side here, or this segment there, and that segment there. So if I name them A, B, C, D on this particular trapezoid, that means that BC is a base that is parallel to base AD. And again, on an isosceles trapezoid, AB will be congruent to CD. Right? So that's the definition of an isosceles trapezoid. Make sure you know the difference between a regular trapezoid and an isosceles. On a regular trapezoid, remember the key thing for a trapezoid is that you will have one pair of parallel segments. However, on a regular trapezoid, it doesn't necessarily mean that the two segments that are not parallel are congruent. But on an isosceles, you have one pair of parallel segments that are not necessarily congruent, and then the other or non-two parallel sides will be congruent on an isosceles. Here's theorem 614. If a trapezoid is isosceles, then each pair of base angles are congruent. So what does that mean? On this particular trapezoid, I have trapezoid ABCD. That means the base angles will be congruent. What's the base angles? The base angle A, base angle B, and base angle C, and base angle D. AB, segment AB is a base, and segment DC is a base. Remember we talked about the bases. Angles A and angle B will be congruent to one another, and angles D and C will be congruent. They'll be on the same parallel line. That's how you'll know they'll be congruent to one another. Okay? Again, angle A will not be congruent to angle D because they're not on a parallel line. And in this example here that I'm showing, angle B is not congruent to angle C because segment BC is not parallel to AD. All right, theorem 615. If a trapezoid has a pair of congruent base angles, then it's an isosceles trapezoid. Here's trapezoid ABCD. All right. So here they give two informations. They tell us that we have a pair of base angles, angle D and angle C. Okay. And they also inform us, we see that it's parallel, that AB is parallel to DC, so that lets us know that this is going to be an isosceles trapezoid. All right, and again, if you have base angles on a trapezoid, you automatically know this is isosceles. Base angles are congruent, I should say. Let me say that one more time before I go too fast. If I'm looking at a trapezoid, I know it's an isosceles trapezoid if the two base angles are congruent to one another. Then it will be an isosceles type of trapezoid. Okay? Theorem 16. You also know you have an isosceles trapezoid if and only if you have here the diagonals will be congruent. So again, I know this is first of all, I know this is a trapezoid because the two bases are parallel. AB is parallel to DC. However, I know it's an isosceles trapezoid because the diagonals AC and BD are congruent in length. AB equals the same length as BD. If that's the case, when the two diagonals are congruent on a trapezoid, then I know that this is going to be an isosceles trapezoid. And again, on an isosceles trapezoid, the two legs that are not parallel, for example, AD and BC are not parallel. I know that those are the two legs that must be congruent. Remember, you have a pair of congruent legs on an isosceles trapezoid. Next, if we're told that PQRS, as soon as the computer catches up, is an isosceles trapezoid, find the missing angle. Okay. All right, here we go. Find the measure of angle P, the measure of angle Q, and the measure of angle R. First of all, we know that on a quadrilateral, those consecutive angles, and I'm bringing this information because it looks like I typed it here. Because it's an isosceles trapezoid, the base angles Q and R are going to be congruent. So that also means that because this is an isosceles, I see that QR is a base and PS is a base because they're both parallel. And I see that QP is congruent to RS. Both those two things happen. And if that's true, the base angles are congruent. That means that angle Q, which is 50 degrees, will be congruent to the measure of angle R, which will also be 50 degrees. Okay? So if the measure of angle Q is equal to the measure of angle R, so that means the measure of angle R will also be 50 degrees. And we know that from what we learned about quadrilaterals in the beginning, okay, on trapezoids, we know that angle Q and angle P form consecutive angles because PS and QR are parallel and QP is cut by the transversal. So here we go. These were two parallel lines and I extended this out like this here. Okay, you see it's being cut by a transversal here. That means automatically that angle Q and angle P are consecutive. And we know that consecutive angles on parallel lines are going to be equal to be supplementary. So that means that the measure of angle Q plus the measure of angle P must equal 180 degrees. And I know that the measure of angle Q is 50 degrees plus the measure of angle P, we don't know, is equal to 180 degrees. Subtract 50 on both sides. The measure of angle P is equal to 130 degrees. Now this is old school where I went back to parallel lines being cut by the transversal QP. That's, you have to go back and review. That's old school. Okay? Consecutive angles here, theorem for parallel lines. Okay? And because angle P is a base angle on an isosceles trapezoid, that automatically means that the measure of angle P is equal to the measure of angle S. Therefore, and I'll put the 3 dots to mean therefore, angle S, the measure of angle S, is equal to 130 degrees as well. Okay? And I'm actually going to divvy this into 3 parts instead of 2.